Hi guys, I'm going to give you kind of another introduction on mole ratios, and then you have a packet that you can work on in addition to some homework questions. So the stoichiometry introduction, this is like page 3 on your pink packets. If you wanted to put that at the bottom, that way you have you kind of know what page 3 is, and when I start referring to pages, because I didn't get a chance to number them. So yesterday we started talking about looking at balanced chemical equations and what that meant in terms of chemical quantities. In this whole unit that we're talking about is going to be looking at when a chemical reaction occurs, trying to determine the amounts of the reactants and products. Okay, so this introduction stuff is all on the PowerPoint that is posted on my DSHA. So if you didn't get a chance to fill that in, definitely take a moment and do that. What I want to just remind you is that, it is important to know that two atoms make up this molecule of nitrogen gas, but really we're looking at quantities that are much larger. We're looking at groups of molecules of nitrogen gas. So we want to really think about using the moles. Gram molar mass is off the periodic table. Our 22.4 liters of gas is at STP. So just keep in mind that we're going to be using these quantities because these are the ones that we can see, that we can work with when we're in the laboratory. Okay, so a mole ratio is really just looking at the coefficients of the balanced chemical reaction. So if you don't remember what coefficients are, they're those big numbers right in front of the compound. So the 1 in front of N2, the 3 in front of H2, and the 2 in front of NH3. And yesterday we started working on these mole ratios, but there's actually 6 mole ratios. So in addition to the 3 mole conversions that we already had, which we talked about yesterday, 1 mole of a gas is 22.4 liters at STP. 1 mole of a substance contains 6.02 times 10 to the 23rd particles, and 1 mole of a substance weighs the gram molar mass looking at the periodic table. Now we're going to add mole ratios as additional mole conversions that we can use, but these are specifically used to move from one substance and another in a balanced chemical reaction. Okay, so let's just take a look at the N2, the H2, and the NH3, and let's write out those mole ratios for that. So if I have sorry, I don't know why this stuff's gotta bug me. 1 mole of N2 plus 3 moles of H2 reacts to produce 2 moles of NH3. And like I said yesterday, this is the Haber-Bosch process. It's fun to challenge you guys to think about where we might need ammonia. So be ready on Monday. I'm going to ask you a couple questions in terms of, some biology you would have had in fully understanding, like why is ammonia important, and where do we often see nitrogen compounds in living organisms. So just know that is coming. But we did start working on this yesterday, and 1 mole of N2 can be related to the 3 moles of H2. And you're asking, why is this? Well, think about when you make cookies or any kind of a recipe. If I start with a certain amount of ingredients, like let's say I didn't have enough flour and I had to adjust my recipe, I need to figure out how the other reactants in that recipe need to be adjusted. So you do this math in your head often. It just seems weird using chemical compounds and the mole. So one of the mole ratios you could use would be 1 mole of N2 over 3 moles of H2. This would be used in an example where I maybe have a certain amount of hydrogen gas and I want to know how much nitrogen gas I also need in this chemical reaction. In using mole ratios, we can just flip them, and that counts for a second mole ratio. So what would be the flipped mole ratio of this one that I already gave. Hopefully you came up with 3 moles of H2 over 1 mole of N2. So now I have 2 of my 6 mole ratios that I could use for different kinds of calculations with this balanced chemical reaction. Another one I might use is I might want to compare nitrogen to ammonia, because maybe I want to know how much ammonia I'm going to produce or be able to make if I have, how much nitrogen I need for a certain amount of ammonia that I was able to produce. And if I flip that, then it would be the opposite. If I have a certain amount of nitrogen gas, I want to see how much ammonia could be produced. Okay? And then lastly, the last ratio we're going to look at is between hydrogen and ammonia. And again, when we have these mole ratios, really they are helping us solve specific problems. So I'm not going to always need all of them. I'm just trying to make you aware of how many different problems we could do in this chemical reaction. So just looking at the coefficients, there's 3 moles of hydrogen, and we can compare that at some point to the moles of ammonia produced. And remember, everything's the conservation of matter here, so we need to make sure that we're using a balanced chemical equation in order to create these mole ratios. Okay, so a mole ratio is really just a way for us to conserve particles, and in the laboratory, because we can't count particles in moles, we have our conversions, our gram conversions, our liter conversions for gases, in order to actually do the chemical quantities in a laboratory. But we need these mole ratios as a way to make sure that we've counted our particles correctly. So we're kind of combining multiple ideas that we used first semester. Okay? All right. So if you flip to page 4 in your packet, it says how many moles of ammonia are produced when 0.6 moles of nitrogen reacts with hydrogen. So just to make sure you know where we are, we're going to go to page 4, mole to mole problems. How many moles of ammonia are produced when 0.6 moles of nitrogen react with hydrogen? Okay, so now what I want to do is I want to look back at my mole ratios, and I'm trying to find the amount of ammonia produced when nitrogen has 0.6 moles. So really, anything that involves hydrogen I don't need right now, because I'm looking at a comparison of how much reactant of nitrogen I have to how much ammonia I have. So I want to think about these 2 mole ratios and how I would eventually find my product, okay? Or the question that's being asked. So if you look at that example problem, it says 0.60 moles, and you're going to have to remember how to read word problems, right? Those can be challenging. So if you look, it says 0.60 moles of nitrogen reacts with hydrogen. Okay, so I'm going to start with my given, which is I have 0.6 moles of nitrogen. I don't have a full mole, so I can't just use the mole ratio, but I know that it's like a little bit more than half of a mole, so I can kind of use that to guide whether or not my answer is correct. Now, if I look up here at these 2 mole ratios, how do I use them in order to cancel out units and get to what the question's asking? The question says, how many moles of ammonia? Okay, how many moles of ammonia? Well, I don't know the number of moles of ammonia, and I'm starting with moles of nitrogen. So in order to cancel out moles of nitrogen and find moles of ammonia, which of those 2 mole ratios should I use? I hope you realize you need to use this one. So I want to use that mole ratio to help me conserve particles to see how much nitrogen is needed to produce that amount of ammonia that also contains nitrogen. So if you double check this, your moles of nitrogen cancel, you're left with moles of ammonia. That's what the question asks for. It's a 1-step problem. So you take 0.60 times 2 to get how many moles? 1.2 moles of ammonia, which makes sense. A little bit more than half, but it wouldn't be quite that full 2 moles. Okay, so example number 1 gets at, right below that one on your pink packet, gets at a different chemical reaction, and it wants you to write the 6 mole ratios for that. What I'm going to do is I'm going to have you guys work on these example problems. And there is a POGIL packet that will help you practice more of these types of problems. And we will go over those on Monday. Now, if you're still looking for more work to do, page 7 of your pink packet, it says mole-to-mole stoichiometry homework. So if we go back to the packet, mole-to-mole stoichiometry homework. Oh, the computer got mad. This will help you practice some more of the same types of problems. My expectation is that if you finish the mole ratio POGIL, you would work on this. Use your time wisely. The more work that you do here today and next week and practice this, the less you'll have to do over winter break, because we're going to want to do some quizzes and things after winter break. And so if you learned anything from the last unit, you really have to practice these problems. They have to become easy. Mole to mole needs to be easy because we're going to get 3, 4, 5-step problems that get to be more complicated. And then don't forget, in your textbook, I will put the homework on my DSHA, but we're in chapter 9, and there's some example and practice problems there that will help you if you get stuck. My DSHA also contains a couple of extra videos on practicing this and learning and understanding stoichiometry and the calculations that we're going to be doing. So please look at those resources if you're having troubles, and bring all your questions on Monday. And I hope you guys have a very wonderful weekend. If you want to see me during Dasher time tomorrow, Friday, that's a-okay with me. And otherwise, I will see you guys on Monday. Have a safe and healthy weekend, and we will keep working hard on this. All right, bye.